record this right now. So, what we're gonna do?
Wait, Mr. On or off?
Off.
Oh, okay.
So,
wait, Mr. Since mine is off, I actually have like a profile picture. Do I turn on the camera and like face it up to the roof or something?
if you want to, yeah, that's fine.
Yeah, because I don't want to cause you any trouble for like editing or whatever.
Yeah, editing is not good. It takes time.
I know, Mister. I know.
So, and some people like it. Some people like editing. I don't like it. That's time consuming. So, all right. So, section 3.2 was on the multiplication rule and conditional probabilities. So, basically, when you see an and, you're thinking about multiplication. Now, here we're going to deal with the addition rule. And so, the first concept they have there is about something referred to as mutually exclusive events. And that's not to be confused with independent or dependent events. That's two different things. The independent dependent event have to do with whether a previous event had an effect on the current event that you're looking at. In this case, what we have is whether two events can occur at the same time. If they can occur at the same time, they would be represented as if they were completely exclusive. The overlapping of the events doesn't happen. If they're not mutually exclusive, then they overlap. It feels weird to say it because you're thinking that it won't overlap sometimes, but not mutually exclusive means they won't, they overlap. Mutually exclusive means they're separate. So that's something to kind of keep in mind.
Mister, you want us to cover this down, right?
If you want to.
Oh, okay.
The reason I have
Yeah, I'm copying it down right now.
I see some people writing, that's why I'm just waiting. May I move forward?
Yeah.
Okay, so let's look at these two events there. We got event A, roll of 3 on a die. Event B, roll of 4 on a die. Now, are those events mutually exclusive? Can you roll a 3 or a 4 at the same time?
Yeah.
No.
Wait, with 2 or 1?
All right, let me explain to you how it would not be mutually exclusive. So they're completely separate. They're completely separate. Look, what about rolling a 3, event A, and event B, rolling odds? Can that happen at the same time? Is 3 odds?
Yeah. Yes.
Is it 1 or 2 though?
Just 1 die.
Oh, I thought it was 2.
Okay, yeah, if it were two, yeah, it could happen. If it were two dice, of course it could happen. But if it's one die, you can't, 3 and 4 can't happen at the same time, right?
Yeah.
But what about 3 and odd? Can that happen at the same time? Yeah,
Yeah.
so in this case, this will be mutually exclusive. That would definitely be mutually exclusive. I'll wait because some people are writing.
Oh, so if they occur at the same time, then I can't use the exclusive.
Yeah, they would be not mutually exclusive. They would have an overlap. Does that make?
Okay.
Yeah, we'll do more examples, and obviously we'll have more work to discuss about it, but basically, you know, that's the main concept.
What if they give out like the same number? It's still like you rolling it at the same time. You can't.
Well, we're rolling only one die right now, right?
Oh, okay.
If you consider two events of the same die rolling,
Yeah.
okay? So don't over.
Okay.
We'll see more examples, and I hope you get a feeling for it.
Okay. Thank you.
Now look at this one. Event A is you select a male student. Event B is select a nursing major. Can you be a male and a nursing major at the same time? You see that? Can that happen at the same time?
Yes.
Therefore, that's not mutually exclusive because they can overlap. They can happen at the same time. Does that make sense? Make sense?
Yeah.
All right, still some people writing. Okay. So take a look at this new rule here. It's called addition rule for probability. The probability of A or B must equal the probability of A plus the probability of B minus the probability of A and B. And the reason we do that is you'll see very soon that you would end up counting A and B twice if you proceed with this rule. Now, if you have mutually exclusive events, probability of A or B is just a probability of A plus the probability of B because there is no overlap. There is no overlap. And if you have more events that are all mutually exclusive, you can continue. In other words, if you have the probability of A or B or C or D, and they're all mutually exclusive, you just keep on adding them. All right, may I move forward? So take a look at this question. It says, you select a card from a standard deck. Find a probability that the card is a 4 or an ace.
1 and 8.
Well, let's do the question carefully. We're picking one card. How many 4s do you have in the stack?
4.
How many aces do you have?
4.
Okay,
Or 8 out of 52 or whatever's in the standard deck.
well, that might be the case, but let me ask you a question. Is there an overlap between 4 and ace?
Yes. Well, no, not the 4 and the ace, but the 4 and the 4 and the ace and the aces.
Okay, so let's think about it. An ace is an ace. It's not a heart, it's not a spades, it's not a club, it's not a diamond. But, so we have a 4 of hearts, a 4 of spades, a 4 of diamonds, and a 4 of clubs. And we have an ace of hearts, an ace of diamond, an ace of spades, and an ace of clubs, right? Are there any overlap between those? Did I count anything twice?
No.
So these events are mutually exclusive. So then all it would be is, you see that? You see that they're separate? Or is there any overlap between the 4 and the ace?
No, sir.
There you
No.
go. So now, that means that it's just gonna be the probability of 4 plus the probability of ace, 8 out of 52. Make sense?
I'm a
Yeah.
genius, mister.
Oh yeah, now I get it.
That's right, Vicente, you understood it.
Can you give me a second so I can copy?
Yes, get coffee. Coffee's good for you, I guess.
What's the name of this lesson?
Addition rule.
Mister, you're good.
Mister,
Yes,
this is recorded, right?
yes.
Because I missed a couple slides.
It's being recorded, so don't stress. Plus, this PowerPoint is in your files for our teams.
Oh, okay, thank you.
Okay, take a look at this one. It says you roll a die. Find the probability of rolling a number less than 3 or rolling an odd. Can the number 3, when you roll one die and an odd, happen at the same time?
You might roll 3, yes.
There you go. Oh, sorry, less than a 3. I read the problem wrong. Less than a 3. Can you roll less than a 3 and an odd number? The answer is yes. What's less than
3.
and odd? The number
3 and 1.
Well, less than 3, that means 3 doesn't count.
Oh, 1.
But do you see the Venn diagram? Do you see where they overlap?
Yeah.
So these events are not mutually exclusive. So here's how you do it. you take the probability of less than 3 plus the probability of odd, but then you have to subtract one of them. Why would you have to subtract one of them? What is less than 3? What results are less than 3?
2 and 1.
1.
0, 1, 2.
Well, 0 doesn't count because
Yeah, no, 0, never mind.
the die. Okay, so now what's odds?
1.
1,
What else?
3,
3.
Oh, 3 and
5.
5.
But do you see that when you add 2 6 plus 3 6, you would have counted 1 twice?
Wait, what was it?
What?
Right. So what's the probability of less than 3? 2 out of 6, right? Because you had the numbers 2 and 1.
Oh,
And then when you do a probability of odd, it's 1, 3, and 5. So that's 3 out of 6, right? But wouldn't I have counted 1 again when I did the probability of odds?
so you have to incorporate that too? Like you have to like
That's why
put
you
that
have
into
to,
the probability as well?
that's why you have to subtract the probability of less than 3 and odd, because that can happen at the same time.
Oh,
Do you understand that? That's really important to understand.
So where
Can
they
you
get the
repeat?
2 to 6? That's the 2 out of 6.
Okay,
the odd number, right?
let me show you what I mean, and let me stop sharing this.
Oh, I got it, mister. I got it. I got it.
Got it?
Yeah, I'm good.
Yeah, I think I got it too.
Okay, let's just,
No,
okay,
no,
so
can you do it in the board?
I'm gonna do it on the board. So this is important. Now, for those of you who are paying attention, obviously, it's important. For those of you who are not, well, I don't care. Do whatever you want. All right. So we're doing the probability of less than 3 or, what's the other one?
Odd.
Or odd. Less than 3 are, so this is event A, this is event B. Less than 3 would be 2 and 1. And there's a reason I wrote this guy here. Because it's going to be also odd. And what is odd? 1,
3 and 5.
3, and 5. 4 and 6 are outside. So here's our universe. Here's event A, event B. What's the probability of less than 3? What's the probability of less than 3?
2 out of 6.
6.
So this guy and this guy. What's the probability of odd? What's the probability of odd?
3 out of 6.
1. What? 1.
No. How many odds?
Oh, 1, 3, 5. So it's 3 out of 6.
Yes, but guess what? Didn't I count 1 again?
Yeah.
Oh,
That's why you subtract. That's why the probability of odd, and then you have to subtract the probability of less than 3 and odd, because you would have counted it again. Because you counted it again. It's 1, 2, 3, 4, 4 out of 6. But when we do this process here, where we take probability of this one plus the probability of that one minus their intersection, because you would have counted it twice. Does that make sense?
Yes.
yeah, I get it.
Got it? We're good?
Yeah, now I get it.
Good, 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 good.
And that's only for when they're not reproducing.
Correct. That's when they have an overlap. When they have an overlap. Okay. May I proceed, guys?
Yes.
All right, take a look at this.
Okay.
Take a look at this one and see if you could do it on your own. Wait, let me share because I'm not sharing.
So how much was that, like 0.67?
Yeah, 406, correct.
Is that the one we're doing?
Yes, see if you could do it on your own. Guys, I'm gonna be right back at the pause of recording. I have to go to the bathroom. Okay, so let's go forward. So it's just that, right? And that.
Yeah.
You use that.
16. Yeah, I got that.
Okay,
No, I did not get that. What?
so let's see. Let's go back to the question. It just says, if this sales pattern continues, what is the probability a sales representative will sell between 75,000 and 124,999? Well, between 75,000 and 99,000, there's 7. And between 100,000 and 124,999, there's 9. So you just add them together. They're mutually exclusive. And that's it.
Yeah, I read wrong.
Okay. So that's it. Now try this one. This one's a little bit more complex. Give it a shot.
Good morning, teachers and students. Please pardon this interruption. Teachers, a quick reminder to please make sure to do the survey regarding how many students are in class physically. Please help us with the survey. Also, teachers, today is our Thanksgiving luncheon. Please come during your lunch to the coffee room in the main office for your meal. Thank you and have a wonderful day.
Mister, I got 348 over 409.
Okay. So let's take a look at what the question is. Find the probability a donor has type O or type A. Type O, type A, 348,049, you would be correct. Make sense?
Let's go.
Any questions, guys, on this one?
No, not really.
Okay, may I move forward?
Yeah.
See if you understand how to do this one. has type B or RH negative?
So wait,
Wait, I think I got the wrong number. This cannot be now.
It will be 110 over
110 over
409.
409.
Okay, so let's see. What's the probability of type B?
It is 45.
What's the probability of negative?
65.
And do they have an intersection?
Yep.
Oh.
Oh, wait.
You have to subtract 8. You see it?
Wait, why do you have to subtract 8?
Yeah, why A?
Okay,
Oh, because it's only asking for B.
all right, let's do this. Type B.
Never mind, don't listen to me.
Type B is 45 out of 409. Negative is 65 out of 409, right?
Yes.
But when you did negative, you recounted at 8 in the middle. Whereas type B,
Ah,
Oh, that
verdad.
makes sense.
there you go.
Okay, that makes sense.
There you go. That's why when they're not mutually exclusive, when they have an intersection, when they have something in common, you have to subtract it. Some people say, well, why don't you take it into account? Because it's a lot harder to do that. So you just systematically do probability of type B plus the probability of RH negative minus the probability of type B and RH negative.
It's just so we don't count it again.
Correct.
So wait, let me get this straight. So it's 8 over 45 plus 65 over 409, and I need to subtract that
So it's
by
45 over 409 plus, plus 65 out of 409 minus 8 out of 409.
Ah, verdad, verdad.
And you see why? Because that 8 in the middle would have been recounted twice.
Yeah.
Yay? Nay? You good?
Yeah, I get him. Yeah, I get it, mister.
Good. May I move forward?
So it'd be 102 over 409. Hey, let's go.
Okay. Yeah.
What was it getting 101?
All right, 65. That's 65.
45 plus 65 minus 8, right?
Yes.
I keep getting 101. Oh, yeah.
There you go. All right, may I proceed, guys and gals?
You may.
Okay. So that's it for section 3.3. Right? I don't know if I want to go into additional topics in county. I'm probably not going to. But what I want to make sure that you guys understand is how to do these problems. So right now, I'm going to go ahead and put an assignment on Teams, which you'll start working on. And I'll have a review on it, and then I'll collect. Fair enough? On Teams.
Mister, you're collecting it today?
No, not today. Not today.
Oh, okay.
not today. Just to give you guys a heads up, give me 1 second. There's a few of you who didn't do the assignment. Carlos Quesada. Yes, it's fine. Oh, let me knock it off.